All right, we're going to quickly go over X-ray crystallography. You don't need to know a whole lot about it. It does give further evidence for the structure of molecules. In particular, it gives a 3D picture of a molecule with bond lengths and angles. Okay, so what happens is a crystal of the material is irradiated with X-rays. Okay, this is what a X-ray crystallographer. It's what the machine looks like. You can make fun of me in class. All right, so what happens is you have the X-ray gun shooting X-rays to crystals of the material, and we get diffracted rays as they go through the material, and that is caught on film. This is actually what one looks like, and from these patterns, they are able to put together through using computers and whatnot this final picture. So if you've seen pictures like this of like DNA, it comes from the X-ray diffraction. Right, and this just gives you a little bit more detail. You really don't need to know much more than X-rays are put through a sample. The X-rays are diffracted within that sample. That film then is developed to get a clear picture of location of atoms and bond angles. Okay. So what can X-ray crystallography be used for? To determine the molecular formula? Nope. It can only locate an atom in space and give us some idea of the crystal structure. Okay, you really don't know what elements are present. Stereochemistry? Yep. X-ray diffraction basically reveals the relative positions of the atoms in space, so absolutely you can use it to determine stereochemistry. Bond length? Yep. Distance between atoms? Yep. Electronegativity? Nope. Lone pairs? No. Formal charges? No. All right. So, looking at it quickly, you do have to get some pretty pure material to start with. You mount the crystals in the machine, you get the diffraction pattern by passing X-rays through that sample, and those are diffracted. They get that diffraction pattern to an electron density map, and then you eventually end up with a 3D structure. And that's about all you need to know about X-ray crystallography. The other piece that we need to kind of highlight that I don't think I made crystal clear before is what range of electromagnetic radiation is used for each of these analytical methods. Infrared spectroscopy uses the infrared region. Okay. Proton nuclear magnetic resonance uses radio waves. X-ray crystallography uses the X-rays. All right, so make sure that you know that. I think the only one that perhaps is a little bit difficult is remembering that the NMR uses radio waves. That's the end of this screencast.